It looks like we're here for day 5 of Advent of Code. I took a look at the problem before this. It looks like the parsing is really simple. So I'm going to start on the data modeling and problem solving side of this problem. And if I have time, I'll get to the parsers. So this problem involves ranges of IDs, and then we need to answer the question, given a specific ID, is this in any of the ranges? There are a lot of solutions ways you could probably solve this problem. The big hammer that I'm planning on using is just to merge the ranges into overlapping contiguous ranges and then just do a simple range check. So let's get started on that. The first thing we're going to need is some way of marking a range. Let's see. ID range, and in there we have two values. We have lower bound, and I'm just going to go ahead and use word 64 because I'm using a 64-bit machine and I don't care. I know these aren't going to be signed. And upper bound. All right. Okay, and we might have to do this. All right. Oh, there we go. Okay. I just might have needed to quit in order to start the language server back up, but it looks like everything's working. All right, we're going to need that. And then to model the merging, what I really want is to split each range into its endpoints and then tag whether it's a left endpoint or a right endpoint. So we're going to use the sum half of algebraic data types. So we're going to which endpoint, and I've actually thought through how to solve this problem of merging intervals in a more general sense. But for this, I'll just go ahead and put just the two. So we have endpoint or right. And if you needed to merge intervals that were possibly open or closed, you would have closed left, open right, open left, closed right. You can work it out for yourself, but if you go ahead and merge that, or if you run the algorithm on the right with those four in that particular order, it'll work. Let's see. I'm pretty sure the Git repo should be in the description for day 4. I went ahead and updated it. I did finish it. If it's not in there, ping me and I will just give you the repo directly, but it should be in the description for day 4. Let's see. So we have the two endpoints. And okay, and then we're going to create a data structure to represent an endpoint. It's going to glue, let's see, the two things together. Let's see. And we have we have the tag. And this is going to be important because we're going to stick these values into a set or into a list, and then we're going to walk through them in order, and so we need the left endpoints to come before the right endpoints. So we're going to do that right now. And this order right here, it's important to note that the default order that gets generated for a product type will sort will sort in the order you create the different cases. So in this case, all the left endpoints will come before all the right endpoints in the default sort order. And that's what we want. Okay, let's see. We have, okay, an endpoint. Actually, I'm just going to ungeneric. I'm going to not make this generic. I'm just going to go ahead and use word 64s everywhere. If I need to solve the generic problem, I can always revisit it. Okay, so now okay, so this is what I'm thinking, that I'm going to have a function to merge ID ranges that will have a list of ID range. And in fact, what I don't want is the list of ID ranges. What I want is a set of endpoints. Okay. Okay, so the first thing we're going to do is we're going to have make sure we have the correct imports. Oh, and in order to do that, we need the containers package, I'm pretty sure. And we'll go ahead and do that. While this is thinking, the idea will be that for each that we're going to stick all of the endpoints into a set, turn that into a list, walk the list, and if we're careful, as we walk that list, we should be able to keep only the endpoints that we need, and then we can rebuild the set from that list. And in fact, we can take advantage of the fact that that list should still be in order, as we've only pulled things out of it. There we go. Okay, that's what we want. Okay, first. Okay, we're going to build the full set. And we're going to do set from list. All right, we're going to write a make endpoints function. Takes an ID range, produces a list of endpoint. That's right. And because it's going to produce more than one, this is essentially flat map. So we're going to take the ranges. Each range is going to produce 2 endpoints. But since we don't want a list of lists, we just want a single list, we just went ahead and used the bind operator. I'm not doing it for style points. It's just how I would write it if I were writing code for myself. Let's see. We're going to go ahead and use record wildcards to make our life easier. And we want value equals lower bound, and that is going to be a left endpoint, and then as an economist would say, mutatis mutandis here, we're going to change what needs to be changed. The upper bound, and that's going to be the right endpoint. And now it's complaining that we don't have record wildcards turned on, but I know the magic incantation, and we want data.function. Especially since I'm using the bind operator, which goes this way, it makes sense to go ranges, make endpoints, and then continue it from the list. There is actually a version of the bind operator that goes the other direction if I wanted to write it going from right to left. All right, and we're going to do, import data.set as set, and yes. And these sets require that the data be ordered. So we'll go ahead and make sure that it is orderable. Okay, and perfect. All right. So now we have the full set. And we're going to loop over this. It's going to take okay. So we're going to turn it back into a set, and we're going to run the merge loop, and each time we enter the merge loop, we're going to have a state variable. That state variable is going to track essentially how many left endpoints we've seen without a corresponding right endpoint. If you think about it, if you have the two intervals 1 through 3, and then 2 through 5, or 1 through 5 and then 2 through 3, they'll both produce the same sorted order, but they also both produce the same merged interval, namely 1 through 5. So just a quick sanity check that what we're doing is reasonable. All right, so to list full set. Okay, so merge loop. Okay. So we're going to do the merge loop. We're going to handle the base case first. Since this is a function from list to list, I really don't care how many open I've seen when I reach the end of the list. I'm just going to return the empty list. That makes sense. And I could do a sanity check that the input was well formed, that right, like it should be an error if you reach the end and you aren't back down to 0. But I'm not going to. Okay. Okay, the first thing that we need is if we are at 0 and we encounter an endpoint I think I can write a pattern like this. We'll find out as soon as the okay, so first thing that we need is if I'm currently not in any endpoints and I find a left endpoint at any value, and we're going to just keep that. So we're going to keep it, and the way that we write that we keep it is we're going to make sure that that endpoint is in the result loop. So 1 and actually we're going to do it. This is becoming unwieldy. We're going to write this a little differently. Let's see. Oh, tests. I, as a part of this, have a test suite for each day of the advent of code. It is just basically the example, the small example that was provided as a part of the problem statement. But it does kind of walk you through how to write kind of a standard, you know, what you would write in Java unit test in Haskell. I also reach for something like Quick Check or Hedgehog. I haven't used Hedgehog. I've only used Quick Check. But property-based testing, especially if there are properties that I can state easily about the code that I'm writing that would be otherwise difficult to check, or difficult to check in a unit test. Some code is not very conducive to property-based testing, but the more kind of abstract and algorithmy it is, the more you can lean on that style of testing as well. All right. Let's see. Okay. So, yes. All right, and we're going to test ep dot we're going to use a guard here. Oh, and we want overloaded record dot. All right. And sometimes the right option when you get a type error that doesn't seem to make sense is just to take one of your local variables and give it a type signature. Really help the compiler out, but it will also help the compiler help you, because when you tell the compiler, hey, I meant to write this, it helps the compiler much more to say, no, you didn't write that. So merge loop is going to take a list of an int and a list of endpoint, and it's going to produce a list of endpoint. Okay, and now it should be just warning that this is non-exhaustive. Okay, thank you. I figured it was non-exhaustive because I wasn't done. Okay. And okay, and if we get it to 1, and we happen to be at the end. Let's see which endpoint. Right endpoint. And they're also going to keep that endpoint. And we're going to decrement. We were at 1, we're down to 0. This is the symmetric version of the case above. And okay. And now the two other cases. So if I have open right. Oh no, and so this is where this one's going to differ. So so we can go ahead and drop that case, and we can do this. And the compiler has gotten very good at exhaustiveness checking. So when I change this to right endpoint, if I can spell it right, let's see, pattern matched P, where not P is not 0 or 1. I'd swear that's handled. We're going to ignore that for now. Okay, we're going to import toList. All right. And let's go ahead and see what happens if we try. And so you can always use a constructor in Haskell as a function that takes positional arguments, so lower bound, upper bound. It's not good style if it has more than, I'd say, 3 arguments to do this, but in our case, it makes for a nice, concise example with the eval plugin. All right. Okay, perfect. That's what we hoped to get. It's a little verbose, but I hope you can see that we get a set of endpoints with 2 things in it. 1 is a left endpoint, and 5 is a right endpoint. All right. I might just have to figure out how to silence that warning, because I'm pretty sure it's wrong. All right. So now, what I want to do is, given a value, I want to determine if it's in this set of endpoints right? Like, so I have a set of ranges. I've reduced it to a merged set of endpoints, and now I want to do a range check and find out, given this thing, is it in a range? And in fact, that's relatively simple to do with the Haskell set type. What we want is that's the type we want. Okay. And there's a long and gloried tradition of calling these things needle and haystack. And we're going to follow that tradition today. And let's see. Hold on with me. So I'm going to pull up the description for data.set. The other place that I often, so the two places I'm usually at when I write Haskell code are in my editor, especially with the help of the eval plugin, meaning I have to go to the console less and fire up the read eval print loop. It's a shorter feedback cycle than reloading everything. And oh yes, min max query. Okay, and then there are 4 functions: lookup LT, lookup GT, lookup LE, lookup GE. So what we want to do to determine if we're in range is, and it's symmetric, we could do it the other way, but we want to construct a left endpoint with the value that we have, and then find what is less than or equal to the value we constructed. And if what we find is a left endpoint, then we're in an interval, and if what we find is a right endpoint or the edge of the set, then we're not in an interval. So okay. All right. First, we're going to build the actual value we're going to use to query the set, and we're going to make it a left endpoint. There's probably other values that we could use, but this one should work. Let's see. Set dot lookup LE and endpoint needle, and then in the haystack. Okay, that's what we needed. Now we need to basically handle the various cases of what this might return. Okay, if we didn't find anything, we're definitely not in an interval. So that one's easy to handle. False. And oh wait, that's, and the ability to add guards to let's see. Oh, it's going to complain about add lookup LE to list of data. Okay, that's what we want. All right, we can just go ahead at this, and in fact, we can do that here too, right? Like, we have handled all the cases. But it is perfectly acceptable if you've handled all the cases to stick this in. If you're code reviewing someone's code and they've written something like this where they state that it's impossible, you should sit down with a pencil and paper and make sure that they're right. Sorry. All right. Okay. We are back. All right. And let's go ahead and try and evaluate this. Let's reuse the result here. This is more concise than writing out the actual set. That's not what I hope to see. Well, let's see where we messed up. Okay. Oh. It helps if at least one of the cases returns true. That looks better. Let's make sure that we'll double check a couple things that should be outside. Then we'll double check the endpoints. All right, there we go. Okay, and the eval plugin will evaluate this entire block at once. So 3 is in, 0 is out, 6 is out, 1 is in, 5 is in. Okay, good. That's what I was hoping to see. All right. So let's get started on our parsing. Okay. And we want, sometimes this is overwhelming when there's a whole bunch of choices, but we definitely want 16. And it's going to complain, yep, that we haven't written it yet. Okay. I'm just going to put this in here so that I can see the data types while I'm working on this. We'll do this right here, and we'll move my camera down there so that you can see it along with me. And we're going to write this one in the monadic style. I find that easier if I'm going to use the named fields when I build the final result. So okay, we're going to parse one decimal number, and then we're going to ignore this, and we're going to use the void function to specifically ignore that. And then we're going to use record punning. We'll fix these one at a time. We're going to import decimal. And we're going to import string. Let's see, add string to the import list of data out, so 19. Sometimes it and we're going to turn on overloaded strings. Oh, and it's warning me about something because it doesn't know what void's type is. We're just going to import void. There we go. All right. And okay, so we can parse a range. And then we're going to define, because of the way that this is written, we really need to parse all of the ranges before we can do anything with the remaining data. So we're going to go ahead and just define a data type for the entire problem. This should be straightforward. It's only going to have two things. It's going to have ID ranges, a list of ID range, and it's going to have we went ahead with word 64. We could define an alias. Maybe I would do that later. All right, let's see. Oh. Ha. Helps if I call the right constructor. There we go. All right. Okay. All right, this should be straightforward. All right, the first thing we're going to do is we're going to parse a list of ranges, each of which is terminated by a new line. Okay. Oh, wait. All right, we're going to use many1 and parse range, and then we're going to keep that and we're going to ignore end of line. And we don't have to worry about end of input because we expect that the input will not stop there, but that there will be one blank line and then at least one ID to query. So let's see. Oh, we don't need the dollar, that's right. Oh, and then we need And I don't trust that this file doesn't end without a new line, so we're going to go ahead and use the utility combinator that I wrote a while ago, end of liner input, and we're going to get the query IDs, and then we're going to use record punning just like we did before in parse range. Pure range problem. All right. And we're going to go ahead and include that. Let's see. How are we doing on time? Okay. Let's go ahead and write an example where we test at least parse range. Oh, haha. Helps if I get those in the right order. There we go. Okay, perfect. All right. Let's see. All right, let's go ahead and write so for each of the days, I have a little utility like this one that takes a file, does all of the magic necessary to produce a result. So we're going to write something like that for today. All right, so count, and let's double check that problem. Let's see. Okay, count fresh IDs in file. Okay. Let's see. And with POSIX file is just a utility that I wrote. It's very similar to, for example, with the with keyword in Python where you open the file, closes automatically. Except Python, you have a bracket. In Haskell, you have essentially a lambda, and the scope of the lambda is where the file is available. So, okay. All right, we're going to parse that. Okay. And okay, so we have the problem. We're going to take the all right, we're going to merge the ID ranges. That's right. And okay, and we're going to take problem dot ID ranges, and then we're going to sum up whether all of the things that are fresh. Now I'm going to use a little trick that I like using, and that's the from enum function. It turns out that if you that from enum takes all kinds of it takes types which are enumerable and produces an integer. And in this particular case, Boolean is enumerable, and the integers you get are 0 for false and 1 for true. It's very convenient sometimes. It's a nice little shortcut. So we're going to take problem IDs, and we're going to you get one nice thing about the ampersand is this works just kind of like a Unix pipe. You can think of just one step at a time transforming the input in map. Okay, is in range. Takes word 64 set bool. Okay. X set. All right. So now we have our list of bools. We can, in fact, do this. There we go. Oh, it's going to complain about this. We're going to import iResult, and we're just going to add it to the import list of the module we already have. All right, and it's going to complain about this. And we're going to, it's a utility I wrote before. We're just going to import it. Open mode, we're going to just import that. And we're going to add default file flags. All right. We're going to import parse with and hgetchunk, and that's the one we want for. Okay, from enum produces an int. Okay. What's it complaining about? Oh, query IDs. Yeah, helps if I use the correct field name. All right, so let me walk this through. It's kind of in reverse order. All right, so we have query IDs for each of them. That's what the map means. The dots here are composition, so you read this from right to left. There is a left to right compose operator, but I just went ahead and did it left to right. You could think of it as the circle operator for math. See, sorry, it's late. All right, we have, we're gonna, for each of the things, we're gonna query whether it's in the set. Then we'll get a Boolean, and then we're gonna turn that Boolean into either 0 or 1 as an int, and then we're going to turn that into a word 64 just so we use consistent types throughout. And there we go. We should be able to use that. So now let's open up our main. I could have used opt-parse duplicative, but things that use the linked list of characters as strings, even for argument parsing, they kind of bother me. I wish there was autoparsec that, or opt-parse duplicative that wasn't string based, and I very well could probably turn this into a library that does this, but this works. I built an argument parser that does things in 2 steps. First, it turns one or more arguments into a list of actions, and then each of those actions acts on some default state. So in this particular case, if you passed day 1 equals, day 2 equals, day 3 equals to each of the, or as arguments to the main function, it would run all of the days for you. I could, for instance, and then I'm using form to as a way of saying, if they requested that we run day 1, then let's run it on the file. And if it's so for each of them, it's let's see, yeah, each one is maybe a value. So the form down at the bottom means run this. We're going to put this over here so that I don't have to worry whether my face is blocking it. The form says if it's nothing, then don't do anything, and if it is something, then go ahead and do the following with the value inside of the maybe. You could think of it as a loop over a list of length 0 or 1. It's probably the easiest way to think about this. All right, we're going to change. Okay. We don't have part 2 available. Let's see, and okay. All right. Okay. Now let's go ahead and make sure that we can compile this. All right, good. My face isn't blocking anything. We're just using the standard Haskell build tool Cabal. So it's compiling day 5. It's compiling main. Perfect. And let's see. Bear with me while I download this. Okay. And we're going to run this and see what we get. Ah. Okay. It looks like somewhere I'm calling the thing for the wrong day. Okay. Oh. Ah, that would be where. Okay, let's try this again. Yeah, it makes sense that the file for day 5 is not formatted correctly in a way that it will parse. All right, so it looks like we get 537. All right, let's see if. All right. Well, that's not right, but I'm going to go ahead and stop here. I have something that's not quite right. I'll go ahead and debug that, but hopefully this has been informative, and hopefully I can get this sorted out.